Hello, today we are going to complete our function and relation graphic organizer. So what you're going to be starting off with looks like this. And then when you're done, it's going to look like this. So you see the biggest box is relations in blue. And inside relations, we have a smaller box called functions. And then inside the functions, the red function box, we've got linear. And a special kind of linear function is a proportional relationship. And then some functions are not linear. Some functions are nonlinear, here in purple. So I'm going to zoom in on each of these sections so you can see all the information that you need to complete this organizer. So relations are not functions, and on a lot of this we cannot put all the possibilities here. I've just given some examples of some possibilities, or I've also chosen to put examples of the ones that I see students missing the most frequently. So right here, this is not a function, and if you use a vertical line, you will see right here, when I hold this ruler vertically, I'm touching here and here, overlapping vertically. So that means I've got two outputs for the same input. It's not a function. Here, when I use my vertical line, so I've got the same input, but I've got all these different outputs for the same exact input. This is not a function. So on a graph, you see not a function, a relation, when it's overlapping vertically. Here for an equation, a relation would be, an example of a relation would be x equals 3. That means that x is always 3, and that goes through the x-axis at 3. That's what it would look like on the graph. On a table, what you would see is same inputs, and it could be this is repeated once, or it could be the whole thing is all the same, but your outputs change. So same input will give you different outputs. That's not a function. It's a relation. If you are looking at a mapping diagram, you're looking for multiple arrows from the same input. So looking at this input of 2, I've got an output of 1, output of 2, output of 3, output of 4. This is not a function, it is a relation. Here, I've got another example. 2 input has an output of 6. The 4 input has an output of 5, 7, and 8. That makes this a relation and not a function. For ordered pairs, if I have 4 and 3, 4 and 1, 2 and 3, 4 and 5, I have the x value of 4 repeating, but with different y values of 3, 1, and 5. That makes this a relation, not a function. For a verbal description, you could have a same input that has different outputs. For example, movie ticket prices for one person. If they go during the day for a matinee, that could be a charge of $4. If they go in the evening, it could be $8. If they are a child, it could be $6. If they are a senior, it could be $7. So different possibilities, different costs for one person. So to sum this all up, we could say if the domain, also known as the x values, the independent variable, the input, if the domain repeats, it is a relation. In functions, there are some possibilities. Here's an example of a nonlinear function. Here's an example of a linear function. So these guys pass the vertical line test. Only one output for every input vertically. Okay, slide my vertical line over my graph. So if my vertical line is only touching one point on this graph at a time, then it is a function. So a vertical line test is there's no overlapping vertically. Again, equation, there's so many options, no way we're going to list them all. One that is frequently missed is y equals 4. So that would be a graph of a horizontal line there. On the table, if you have different inputs, then it's going to be a function. Sometimes what you may see is they will repeat an input, but if that input has the same output as what was already listed up here, then it's still a function. So if you put the same input in and you still get the same output, that's okay. That's still a function. What you're going to look for in a mapping diagram for it to still be a function is that there's one line from each of those inputs. Ordered pairs, same thing. You're going to look at the x values. As long as those x values are different, it's a function. So a verbal description, each input has only one output, one y value for every x value. If the domain is different, then it is a function. Linear. What makes a function a line is that it's got a constant rate of change, meaning that its slope stays the same, and that makes it into a line when you graph it. So straight line is what it looks like as a graph. So it could be a positive slope, it could be a zero slope, it could be a negative slope. Y equals mx plus b. M is the slope, b is the y-intercept. The slope is the x coefficient. For a table, if you have an input of 0 and you have an output of a number here, that's going to be your y-intercept. So this is just an example of a linear relationship here. In a verbal description, you're going to be looking for a one-time fee or a starting amount. Those are going to be your y-intercepts. And some key words for the slope, for the constant rate of change in a linear relationship: every, each, per, weekly, hourly, daily, monthly, yearly, all kinds of options there. Now, a proportion is a special kind of linear relationship. It also has a constant rate of change. And specific to a proportional relationship, it's called a constant of proportionality. So we have y equals kx, where the k is the constant of proportionality. It is the slope for a proportion. You have no y-intercept. Well, you have a y-intercept, but it's 0 for every proportion. So that makes it a straight line specifically through the origin. For example, Earl saves $5 every week. It doesn't state a starting amount, so the initial amount is 0. Here you see the origin listed in the table. So after 1 week he has $5, 2 weeks he has $10, 5 weeks he has $25. You can find your constant of proportionality or your slope by dividing your y value by your x value. Last one, nonlinear has a variable rate of change. These will still pass the vertical line test, even though they're not straight lines. So as I'm sliding this vertical line over my graph, it still passes that vertical line test. Still one output for every input. What you're going to look for in equation is that there's exponents on the variables is what you will see the most frequently. Exponents other than 0 or 1. Here's some examples. Y equals x squared. Y equals 24 divided by x. Y equals the absolute value of x would look like this. y equals 3 to the exponent of x. Here's a fun one. 49 equals parentheses y plus 1, close those parentheses to the second power, plus parentheses x plus 3, close the parentheses to the second power. Y equals x to the third plus x plus 2. All of these are examples of nonlinear functions. In a table, what you're going to see, it's not going to be super obvious maybe, but you're going to have to figure out the slope, the rate of change. So you've got from here to here, that's a change of 1. Here to here, that's a change of 1. So 1 to 1 is 1. From here to here, that's a change of 3. That's a change of 1. So that ratio is 3 to 1, which is 3. Here, you've got a change of 12 to a change of 2, which simplifies to 6. All of these slope ratios are different. They're inconsistent. They're variable, which means they change. So this makes it a nonlinear relationship. So here's my caution. Simplify slope ratios to check for equality. Last. Here's some words you need to watch out for that will indicate that it's a nonlinear relationship. Area, volume, exponential growth. Specifically, bacteria is an example of that. Exponential decay, if it mentions doubling or tripling, or maybe even cutting in half every time. And that's all we have for today. Thanks for listening.